So today we're going to look at a very interesting behavior of water. I mean, there are many. So today we're going to look at a very interesting behavior of water. There are many. Today we're going to look at a very interesting behavior of water. There are many things that make water interesting. One of which is the fact that we're made up of 60% water, but we're going to look at water's ability to self-ionize, or also known as the autoionization. So today we're going to look at a very interesting behavior of water. There are many things interesting about water, one of which is the fact that we're 60% water, but we're going to look at water's ability to self-ionize, also known as the autoionization of water. So autoionization of water. And just by looking at the title, you might be able to get a clue about what's happening here. So if you look at the word auto, for example, you'll get an idea that auto just means that it's doing it on its own. And ionization means that it's creating ions. So what does that look like? So I'm going to take two water molecules, H2O plus H2O. But before I write out the products of this reaction, I want to take a look at the structure of a water molecule. So I'm going to take that down here, and I'm going to draw out the structure of a water molecule. So I have my oxygen here, my hydrogen's here, and remember that water is polarized. And what this negative sign right here is telling you is that the density of electrons is higher in this area, higher by the oxygen than it is by the hydrogens. And this happens because oxygen has a stronger attractive force which pulls the electron to itself than does the hydrogens, which is another way of saying that it has a high electronegativity or pull of electrons. So this is one water molecule that I've drawn here, and in my equation I have two water molecules. So I'm going to draw another water molecule right down here. So again I have a minus and a plus and a plus. And what happens here is between this hydrogen and this oxygen we have a hydrogen bond. So this green line right here represents a hydrogen bond. So what happens in autoionization? So we have our two water molecules, and what happens is that one of the oxygens right here gets such a strong pull that it's able to literally pull off one of the electrons off of this hydrogen, thereby letting this hydrogen go. So it's literally able to pull off one of the electrons. And what happens is that this hydrogen therefore is let go. But this hydrogen doesn't just go off and wander on its own. Since it was already hydrogen bonded to this water molecule right here, it just joins this. Okay? So that our result now is that one of the water molecules, I'll call it this one, has donated one of its hydrogens to this water molecule, and therefore this water molecule has accepted a hydrogen from this water molecule. And if you look at our products now, I have this OH minus, we'll go right here, and this H joined this water molecule, and since this had a plus charge, this will become H3O plus. Okay, so in the beginning I said this is going to be interesting, and maybe you're not that interested so far. But the reason this whole phenomenon is so interesting is because this behavior of water is not unique to itself. And it turns out that there's a whole class of compounds that behave in exactly this way. And what do I mean by this behavior? It's this act of donating and accepting protons that is not unique. And chemical compounds that behave in this way are known as acids and bases. So acids and bases. Okay? And remember, there are two actions happening here. Right? You have the act of donating a proton, and then you have the act of accepting a proton. If you donate, you must accept, and if you're accepting, you must be getting donated to. So that's pretty simple enough, right? So it turns out that anything that donates a proton is known as an acid. And anything that accepts a proton is known as a base. And what I'm going to do here is I'm going to box this definition right here. And the reason I'm going to box this is because you must know this definition, specifically, especially for standardized tests and for MCAT, because this is the definition for acids and bases, and it's known as the Bronsted-Lowry definition of acids and bases.